Hi, my name is Ryan Bartley. I'm a product manager for XR at Google.
Hey, my name is Spencer Quinn. I'm an engineering manager for XR at Google.
Hi, I'm Trisha Becker. I am a technical product manager at Unity.
Hello, my name is Luke Hopkins. I'm a developer relations engineer for XR at Google. It's so great to be able to announce that we're releasing our developer preview for the Android XR SDK. We have a lot to show and talk about today, but first off, who here has built a XR application before? Lots of hands? Yeah, we've got lots of hands here. That's great. If you're porting or building new immersive experiences for using OpenXR, then this is the talk for you. We'll learn about how Android XR as an extension of the Android ecosystem. Next, we'll talk about how Android XR is not only just adopting industry standards like OpenXR, but how we're expanding the capabilities with new vendor extensions. We'll also share how we're partnering with Unity to talk about Android XR for Unity developers. And then we'll end the presentation with a Q&A, which will give you a quick chance to ask those burning questions you may have. We can't wait to show you more, and with that, I'd like to pass it to Ryan.
Thanks, Luke. Android XR is the newest Android platform alongside our expansive device ecosystem of mobile, wearables, TV, and auto. Built on the foundations of Android mobile and large screen development, you can build experiences that span devices and push boundaries when powered by Android XR. Bring your apps to the next generation of devices by going all in on the expansive Android ecosystem and global reach of the Play Store's trusted, secure infrastructure. Android XR offers simplified development by using open standards, such as OpenXR, and familiar frameworks like Unity and Android Studio. Standards and frameworks that let you unlock your creative potential and bring your visions to life across the XR landscape. In the keynote session, we announced the Android SDK. We designed the SDK using familiar Android APIs, tools, and open standards with the goal of reducing the learning curve and leveraging your existing set of skills to the fullest. This SDK gives you multiple ways to build an experience for Android XR. Build native applications using the new Jetpack XR SDK, build immersive experiences directly with OpenXR, or use the Android XR SDK for Unity. If you want to build apps using the Jetpack XR SDK, we recommend tuning into our session called Develop and Adapt Apps for Android XR.
You've heard us mention open standards today, but I want to share more about what that means, why we care about it, and I'm excited that we can finally talk about everything we've been working on in this space. Google has a long history of supporting open standards, and we're actively helping to push the XR industry forward through standards such as OpenXR, Vulkan, and WebXR. These standards provide the best compatibility for your existing applications and ease the burdens and costs of porting. Whether you're porting an existing app or creating a new one, we want to make the Android XR platform a natural fit for all your XR projects.
We're really excited to announce that Android XR is fully conformant with the OpenXR 1.1 specification. In addition, we support a long list of highly used third-party vendor extensions. Using these extensions offers you that familiar experience when developing for XR. Already built an XR application with support for the common extensions used in the XR space today means that you can port your application with ease to Android XR.
Here's a short list of some of the vendor, EXT, and KHR extensions that are supported for Android XR. We have support for tracking and interaction extensions, such as hand tracking, hand interaction, hand aim, and palm pose, so you can create experiences that let users poke, pinch, interact, and use gestures with commonly used XR APIs. There's also support for eye gaze interaction, which can be used to help give input a more natural feel for your users. For performance, there's support for advanced extensions like eye tract foveation, which allows an app to render high-resolution content only at the eye's focal point. And there's also Space Warp extension, which uses velocity vectors and depth texture information to synthesize frames between rendered frames. This reduces rendering load and increases the overall compute budget.
This is so great as an XR developer to know that the OpenXR specification and common vendor extensions are a core part of Android XR platform. Means a lot of the knowledge I have regarding building experiences with OpenXR apply to Android XR. And even better, Android XR is contributing XR Android vendor extensions, and here's some awesome examples. With face tracking, which brings facial expressions to your avatars or skinned meshes. With pass-through objects, which allow for physical objects in the real world to come into your virtual scene. For example, you can bring your physical keyboard, laptop, and other tracked objects into your virtual scene. And one of Spencer's favorite new extensions, Hand Mesh.
Yeah, this one is really, really super useful. The hand mesh extension provides a machine learning derived representation of the user's hands as a mesh. This provides a model that is physically very accurate to users' actual hands. This is an alternative to extensions which use bind pose and blend weights. We see here a short code snippet of how to use the extension. This creates a hand mesh tracker, which can then be queried for mesh information of both the right and left hands, complete with normals and UV coordinates.
With Android XR's multimodal input system, you can design experiences that let users naturally engage with their senses and interact with apps however they choose. Users can interact using their hands, eyes, and voice, and of course, they can use peripherals like controllers and game controllers. XR uses hands as a primary way to interact with the platform, which means users do not need a controller. As Spencer mentioned earlier, we support a wide range of hand tracking extensions, which means if your app already supports this input method and extensions, your work's already done.
Some of these capabilities require runtime permissions. That's because scene understanding, eye tracking, face tracking, and hand tracking provide access to data that may be more sensitive to the user. In keeping with Android's security and privacy policies, Android XR has permissions for each of these features. This is so important for giving users the control, so there's transparency on what permissions are required and for using your experiences. For more information on the list of extensions that require permissions, you can check out the information on the XR developer website.
Speaking of, we recommend exploring our developer site for more information. We have content on designing and planning for Android XR, as well as an overview of OpenXR extensions, getting started guides, and a comprehensive list of Unity packages to use. And with that, we'd like to start to talk about Unity. We've partnered with Unity to bring the Unity engine to Android XR. You can now harness the power of Android XR for Unity to create immersive experiences that captivate and inspire users. We've loved every moment of our partnership with Unity, and with this, I'd like to pass it over to Tricia Becker to talk about OpenXR support and the features found in Unity 6.
Thanks, Luke. What a day. I am so excited to be here and talk about Unity's Day 1 support for Android XR. So whether you're porting an app or you're building something new, the Android XR platform lets you create immersive experiences using the Unity tools that you know and love, like AR Foundation, XR Interaction Toolkit, OpenXR, XR Hands, and starting today, OpenXR Android XR. So with these tools, you'll have everything that you need to support VR and MR experiences, including foundational features like occlusion and persistent anchors that seamlessly blend virtual elements with the real world. The XR Interaction Toolkit lets you use natural hand poses and gestures to interact directly with the virtual space. And with XR Hands, you can go beyond basic gestures too. Our custom gesture detection supports actions like thumbs up, thumbs down, pointing, and more. So you can add extra personality to your interactions. On top of that, Android XR introduces additional features like light estimation and performance metrics, giving you platform-specific tools to optimize and enhance your applications. To help you get started, we have MR and VR templates available today through the Unity Hub, where you can try out many of the features that we just talked about with more updates on the way. Now let's dive deeper into the new features that Unity 6 brings to the XR ecosystem, showcasing how Unity is evolving to meet the needs of XR developers. Unity 6 introduces some game-changing features that are specifically tailored to XR development, from enhanced rendering capabilities to optimized performance on XR devices. One of the most exciting advancements for XR developers is eye-gazed foveated rendering. This feature leverages eye tracking technology to dynamically adjust rendering focus. It optimizes for both visual clarity and GPU performance for smoother, more immersive XR experiences. Another rendering feature we're super excited about is composition layers. So here we've got a side-by-side comparison. On the left, regular texture. On the right, composition layer. As you can see, the use of composition layers significantly reduces artifacts, gives us clearer text, sharper outlines, and an overall better appearance. In Unity 6, we also introduced URP Space Warp. It's a feature that reduces your application's rendering workload, freeing up resources for higher quality graphics and improved performance. You gain additional compute, meaning you can accomplish even more with your render budget. We've got even more coming soon. So in Unity 6.1, we'll roll out new features for Android XR developers, from improvements in developer workflows to advanced rendering options that are designed to meet the demands of next-gen XR development. In 6.1, you'll see templates for creating VR and MR multiplayer experiences. For mixed reality, we're adding a new tabletop game example. It combines the best of our XR support and end-to-end multiplayer solutions. We're also bringing our VR multiplayer template to Android XR. It's packed with everything that your application might require, like networked interactions, voice chat, lobbies, and more. Now, we know that building for XR devices can be complex, and manual configuration leaves a lot of room for error. So that's why in Unity 6.1, we're adding a dedicated build profile for Android XR, making it significantly easier to configure projects with optimized settings for Android XR development. You can also create your own build profiles. The new build profile workflow allows you to create a profile that you can customize based on your project's needs. And since build profiles are project assets, you can save, manage, and share them with your team, ensuring a consistent build experience across the board. So to wrap up, we've covered how Unity 6 works hand in hand with Android XR, providing everything that you need to get started on this exciting new platform. We hope you'll join us on this journey. I can't wait to see what you all build. Now I'll hand things back to the team at Google.
Thank you, Tricia and Unity, for all this amazing work. Unity's day one support for Android XR and the exciting new features in Unity 6 will make sure developers can get started developing today. We recommend upgrading to Unity 6 and URP along with the Vulkan as your rendering API, as this will put your games and applications on an optimal path for the best experience on Android XR. In our next OpenXR session, you will hear from partners that have already started porting their experiences to Android XR, and you will hear firsthand about their developer journeys. Now, in addition to the great packages from Unity, Google has been working on some features in our own package that we called Android XR Extensions for Unity. In this package, you will find early access features and APIs that are generally backed by our new Android OpenXR extensions. Our strategy for this package will be that in time, popular features will be migrated to Unity's Unity OpenXR Android XR package to reduce the number of required packages and enhance API longevity.
Today, some of the features you'll find in the Android Extensions for Unity package include the following. Hand mesh for a system-generated and provided hand mesh that is highly physically accurate representation of the user's hand, complete with UV coordinates and normals. Object tracking for objects such as mouse and keyboard to make it easier for users to locate them when in fully immersive mode. Pass-through layer that allows an application to create a polygon pass-through composition layer cutout of an immersive scene. This is useful for creating areas in your experience that link back into reality. And face tracking for a blend shape representation of a user's face that can be mapped to a user's facial movement and is useful for avatars. We have many more exciting features coming to this package, so be sure to stay tuned for updates. I'll hand it off to Luke now to talk a little bit more about his experience implementing the face tracking extension.
Thank you very much, Spencer. I cannot tell you how easy it was to use face tracking in my project. I'd like to show a quick demonstration of how face tracking works within Unity using the samples that we have provided in the Android XR Unity package. This sample comes with a mesh that is exported with blend shapes, meaning the skin mesh renderer component has all the blend shapes correctly configured for you. This gives you everything you need in order to modify the head's mesh. And then next, we'll get the information from the XR Face Tracking Manager to send to the skinned mesh renderer component. Now, in order to use the XR Face Tracking Manager, we first must start by declaring permissions for face tracking. And then we'll request it at runtime. And again, working with permissions in Android XR is exactly the same as working with permissions on any other Android form factor. We can check in our update function if the user is granted permission to use this feature. And after checking we have permission, we can then check if the extension is enabled. Great. Now we know the XR Face Tracking Manager is ready, we can start reading values. For this example, we're going to loop through all the face parameters from the jaw to the lips all the way to the user's eyebrow. This API provides a weighted value which maps to the blend shape weight method, and this weight defines how the skinned mesh will be modified in that particular area. For instance, if I have a fully raised eyebrow, this will result in a weighted value of 1. This updates the mesh and morphs the eyebrow to its maximum position. Remember, your mesh just doesn't have to be a face. For this example, weighted values can be represented as cushions on a couch. Have fun playing with this feature. I know I did.
So we've talked about space warp and eye-tracked foveation, but there are many other performance features that are also available. Some of these include Vulkan subsampling for enhanced GPU performance, display refresh rate to request optimal frame rate for your application, and optimized buffer discards to reduce unnecessary cached information. These tools can be used to tune your application to get the highest frame rate and quality. The source code for our extensions, as well as samples on how to implement them, is currently available on GitHub. We encourage you to explore the code. You can also check out our API references and getting started documentation on our developer website.
We have also been working hard to create an amazing set of samples to inspire and educate you on Android XR. These simple but playful mixed reality samples will showcase the power of Android XR. Now we would like to show you a video demonstrating all these features. It's so great to see a lot of these OpenXR extensions working in Unity. A few of the examples use different extensions. For instance, we showcased plane detection so that virtual objects can interact with physical space, gaze and pinch as a way to interact with virtual elements by looking at them, face tracking so that you can record random facial expressions so that objects can talk and make faces. Tape measure, which measures real-world distances using depth estimation. And next year, we will be publishing these amazing experiences for you all to see and explore.
Once your app is ready to share with users, you can use the Google Play Developer Console to distribute to users everywhere. For experiences that are only suitable for Android XR devices, Google Play is launching a new dedicated release track for Android XR. This enables you to deliver specific builds to Android XR devices without needing to do things like publish your app under a separate package name. As of today, you can access all the developer documentation, which covers everything we've discussed, along with the instructions on how to get started with Unity 6. Early next year, we'll be hosting bootcamps around the world so you can get hands-on access to pre-release hardware, ask more questions, and have more technical sessions like this with the Android XR team. Apply to our developer bootcamps and get hands-on with the latest technology in 2025. The spots are very limited, so start now. We can't wait to see the immersive experiences you build, so thank you very much for your time, and we can't wait to see you again soon.